Hey everybody, it's Tuesday. It is 3 o'clock. That means it's Tech Tuesday. I'll be right back. We're going to be talking today about IPv4 and IPv6 and how to manage that transition and some common misconceptions about it. I'll be right back. Thanks for joining me. This is Rick Yuzzi with Zcorum, and again today I'm going to be talking about IPv4, kind of the IPv4 dilemma that we have for ISPs, because it's an interesting situation where a lot of the world is on IPv6 right now. There are a lot of ISPs that are still on IPv4, and in some cases they are running low on IPv4 addresses, so there's that whole question of IPv4 depletion and what to do about that. How do you conserve those addresses, and then when to switch over to IPv6, and do you buy more addresses? Do you just switch over to IPv6? Do you deploy Carrier Grade NAT? There's lots of different questions there. And there's really there's I think a lot of misconceptions about Carrier Grade NAT, and people are thinking they can wait out IPv4 and not ever have to deploy that, but that's really not going to work, and that's part of what we're going to be talking about today. So thanks for joining me. At the end of this video, or if any time you like, just hit a like on the video. If it's something that's helpful to you, please do that for us. You can subscribe to our YouTube channel right down there. Just click the subscribe button, click the bell if you want to be notified when we're live. I do this once a week on various topics. So again, thanks for joining me. So let's talk a little bit about IPv6, IPv4, this dilemma that we have here. So one thing that's interesting is with IPv6, there wasn't a date where everybody said, oh, you have to be switched over to IPv6. So unlike, let's say, Y2K, where there was this date where everybody was like, we need to get everything fixed or it's going to break on this date, and everybody worked towards that, and then it turned out to be kind of like a big nothing burger. But it was something that everybody was concerned about, and there was that date you had to hit. In this case, people thought there might be a date, but they never knew when we were going to run out, right? So people kept putting it off and putting it off. And then, in addition, that date kept slipping, right? So as people started getting they started conserving their IPv4 addresses more and more, and some people actually, they had excess addresses, and then the folks like Aaron started requiring people to justify the ones they were using. So people that had been assigned these huge blocks of address space and were only using just a small portion of it, they suddenly had to justify that, and if they couldn't, they had to return those back to Aaron or the other organizations that manage those, like RIPE and APNIC and NIC and whatnot. So eventually the pool started to grow again. So we kept seeing the date when we'd run out of IPv4 addresses keep slipping. So people lost interest in that over time. And then eventually it did happen. We noticed, here you'll see the story back from 2015. North America is out of IPv4 addresses for really real this time, because again, there kept being these warnings of when this was going to happen, and then finally it really did happen, where these organizations like Aaron ran out of addresses. Basically, they said, we can't really assign anymore. So it got to the point where you could not get IPv4 addresses from Aaron. People would still get them on the market or do other things, or they tried to get plenty to hold them over, but we got to this point. And here we are, it's 2020, and there's still a lot of networks that have not been converted over to IPv6 from IPv4, because there are challenges to that. And again, there's just not this real reason for some smaller operators and some smaller content providers to do that. There's not this stake in the ground that says you got to do it by this point. So there's still lots of IPv4 out there, and it's going to be that way for a while. Now, the problem for internet providers is they, as they grow their business and they start giving customers these, a public IPv4 address, they start to get into a shortage situation. And then what do? And we've seen with COVID-19, as more and more people are staying home, and a lot of people are realizing, I really do need a good home internet connection. Maybe just not my phone, something like that. So there are more people signing up. A lot of broadband operators are seeing lots and lots of new data customers signing up. Even if they're losing video customers, they're gaining broadband customers. So there's been a lot of demand, and because of that, if an ISP is on IPv4, there's maybe starting to see a little pinch on the IPv4 addresses that they have. So what do we do? Well, IPv6 is really, the plan. That's where everything is supposed to be going to in the future, and you can see why. So we had 4.3 billion, or we have 4.3 billion IPv4 addresses, and that seems like a lot, and it is a lot, obviously, but it's not enough for every person in the world if we wanted to give everybody in the world an IP address. And at one point, this seemed like enough because all that was on the internet were a bunch of servers at universities talking to each other. That it wasn't really that many people communicating on the internet. But as the internet went commercial and more people started getting on it, and more devices needed public addresses, then it started to get short. So with IPv6, we have 340 undecillion addresses. Now that's a lot of addresses. What is that? That's basically 3.4 times 10 to the 36 addresses, or 10 followed by 36 zeros. If you want to look at it this way, it's 340 trillion addresses. That's enough addresses if we wanted to assign, more than enough addresses if we wanted to assign an IP address to every atom on the surface of the Earth, not the whole Earth, but the surface of the Earth. So that's a whole lot of addresses. So seems like we'd be just fine for now with IP addresses, but we got to get everybody switched over to this, right? So we got plenty of addresses. So where do we go from here? And one of the things that people think is, well, I'll just switch over to IPv6 and be done with it at some point. I can do that, and yes, you can, because there's thinking like there's a zillion addresses, right? So I'll just switch over to IPv6 when I'm ready, and I'll have plenty of addresses. And you can do that, but problem is that not all web services have converted over to IPv6. Excuse me. So you've got lots of content out there that is still IPv4 only. Now, obviously, your large content providers, your CNNs and your Amazons and your Googles and YouTubes and all of the large e-commerce sites and other kinds of content sites out there, they're all able to support IPv6, but you've got lots and lots of smaller websites out there. Some of them are hosted on small hosting providers that have not switched their networks over to IPv6 yet. You've got people just that have their own server up that are not on IPv6 yet. So that's a lot of content that's going to be out there, and it's going to be out there a really long time. We don't know. It could be 10 years or longer before everybody gets over to IPv6. We just don't know. Because again, there's nothing kind of driving that or forcing that to happen at this point. And who is the customer going to blame if you switch over to IPv6 and then suddenly there's some website or multiple websites that they can't get to? Because IPv6 and IPv4 are not compatible natively. They don't talk to each other. You have to be able to translate between those two things. So you can't do that. You can't have customers on an IPv4 network, an IPv6 network still talking to IPv4 content. Just like you can't have your IPv4 customers talking to IPv6 content. But the content providers, those that have switched over, are supporting both. So they're doing something like Dualstack, where they've got both IPv6 and IPv supported on the same network. So if the customer comes in, it doesn't matter whether they're using 4 or 6, they can get to the content. So that's pretty much taken care of on the larger content providers. Again, there's smaller ones out there that haven't done anything. There's a lot of ISPs out there that have converted. Your larger ISPs have converted over to IPv6, or they're doing Dualstack, and in some cases they've got Carrier Grade NAT. In most cases, I think they're going to have Carrier Grade NAT. So they are able to support that customer, whether they're IPv4 content that they're trying to reach or IPv6 content that they're trying to reach. So everybody needs to be getting to that position right now, really, because we are at a point where we should be getting everybody over to supporting IPv6 so IPv4 can go away. So you're still going to need a way for your subscribers to reach IPv4 content while, for some period of time, let's say for the next, 5-10 years in there. And this is the case even if you're going to do a greenfield deployment. So you might be thinking, well, as I open new service areas, I'm going to deploy IPv6 there as well, or only there. But again, you've got the same situation where those customers, even this greenfield opportunity that you have, they're going to need to be able to reach the IPv4 content that's out there. So you can't just switch to IPv6 just alone. Can I run Dualstack on my network? So again, Dualstack is where you're supporting IPv4 and IPv6. So yeah, you can run Dualstack, but that does not resolve your IPv4 shortage. So if you've got a shortage of IPv4 addresses, that doesn't resolve that, because you still have to have an IPv4 address for every subscriber that you have, because they're all going to be able to run IPv4 and IPv6. So that doesn't help there, Dualstack. And again, this is what the larger content providers are doing to be able to support IPv4 and IPv6 together. If you deploy Dualstack, you're still going to need an IPv4 address for every subscriber, as I just mentioned. What's another option is, where is it? Oh, you can buy IPv4 addresses. So you can do this, but this is not a really good long-term solution to the problem. Because again, we just don't know how long it's going to be. So you might think, well, I'll buy enough and it'll get me through, but every ISP is trying to grow their business, and we don't know how many, we don't know what the need for addresses is going to be in the future. As you grow customers, you may open up new service areas. There may be more need for, with the Internet of Things, for more things out there to have public addresses. A lot of them can work off of NATed addresses on a route or something like that, but there may be more public kinds of needs for Internet of Things. So we just don't know how many addresses are going to be needed over this period of time. So you can buy IPv4 addresses, but chances are you're going to keep going back to the well on that, I would think, over this period of time. So unless you buy enough to wait this thing out, which is possible but maybe unlikely for a lot of folks, then that's not a great strategy. And it's expensive. So you know, it used to be, it's really painful, because you used to be able to get IPv4 addresses for free, right? So you would just go request a block of addresses, a /24 or /23 or /22, something, lots of addresses, and you'd have no problem getting those, because we had over 4 billion, and that seemed like a lot. Or you'd get your you'd upgrade your internet connection, and with that would come some addresses from your internet provider. But you know, it's just hard to get them these days. So there are brokers out there, like this is a typical kind of site that you might see, where you can purchase addresses, but again, they're not cheap. Here you've got a Class C address, and that's about that's 254 routable addresses, and we're looking here at $25.50 per address. So that comes out to over $6,500 for this Class C, which is, you know, not overly crazy expensive, but it's not cheap either. And if you've got, again, if you've got to go back to the well on that a lot, then that's maybe not a great way to go. Now you can buy a bigger block. Here's one right next to it. This is a /22. So that's going to have 1,024, I guess 1,022 maybe routable or usable addresses. And the opening bid on this one, this is just, this one was ending in 50 minutes, so this may be where it's going, but it's $24,000 for that 1,000 or so addresses. So again, not a great long-term strategy. It's something you can do, but I think there's better ways to handling that. So I buy IPv4 addresses, that's one option. The other is to deploy Carrier Grade NAT, and this is really the better long-term solution, because in the end, you're really going to have to deploy this anyway. I think there's a misconception with a lot of ISPs, I think, that they think they can wait out IPv4 and never have to deploy IPv6, but I don't think that's going to be possible, because you're always going to have some content that's going to have to be translated out there. And what Carrier Grade NAT does is it resolves the depletion issue that you may have now. So if you're getting short on addresses, it immediately gives you a whole bunch more addresses that you can use by doing NAT. I'll explain that in a minute. And it also provides a way to migrate to IPv6 when you're ready, so that when you do switch everybody over to IPv6, then they can still reach any IPv4 content that's out there. So how does that work? Well, yeah, actually I already mentioned this. So you most likely are going to need CGNAT at some point. And what this can do, if you do CGNAT, is it can immediately increase your address space by up to 128 to 1. So that's quite a bit if you think about that. So again, if you've got that Class C of 254 usable addresses, that could serve up to 35,512 subscribers, or 35,000 plus. If you're doing 128K to 1, as far as oversubscription of one public address to private addresses. And that's a whole lot. And even if you're being conservative, if you want to go conservative, 64 to 1, that's still 16,000 plus addresses that you've turned that one Class C into. So that can make an immediate difference if you're running low on IPv4 addresses. And then even if you do have to buy addresses, let's say you're just really short and you feel like you have to buy some anyway, then you won't have to go back to the well so often. Maybe not at all ever again if you buy a certain amount of addresses and then you're doing Carrier Grade NAT, CG NAT. Because again, whatever you buy is going to go so much further, up to 128 to 1 on those addresses. So you've got two modes that we can talk about here as far as on CG NAT. One is NAT 44, and this would be the one that you use for IPv4 conservation. So basically what you're talking about then is that you're doing this network address translation in this CG NAT box. And basically what's happening here is you're going to be assigning each of your subscribers a private address, and they're going to be sharing one public address. Again, you might have up to 128 people sharing one public address. And the NAT box tracks all of that stuff using these private and public addresses, and then also TCP or UDP ports on identifying which subscriber is which that's sharing that address. And it does all that translation very quickly, so the end user doesn't notice it. There are some concerns that some people have, and I'm going to be talking about that next week on some objections that people have to using Carrier Grade NAT. For example, maybe applications not working, those kinds of things. But CG NAT's kind of built to handle all of that that we'll be talking about next week. So that's kind of how that works. And so you've got out here, you've got your IPv4 content provider, and then you've got your IPv4 network, and you're short on addresses. So basically, again, what you're doing is you're doing this network address translation to public to private addresses so that you can then support a lot more customers with the number of IPv4 addresses that you have today. So that's NAT 44. And then you've got NAT 64, and the purpose here would be if you switch over to IPv6, again, you've still got IPv4 content out there, and how do your customers talk to that? So what NAT 64 does is you've got your Carrier Grade NAT box here, your CG NAT box, and you've got your customers on IPv6, and when they go out to find a website, they check with this DNS 64 server that you set up in conjunction with this, and that server it checks with the DNS server and finds out if there is a IPv6 address for that particular website. If there's not, then the DNS server returns an IPv4 address. So basically, this box here handles the communication as to whether there's an IPv4 address available or not, and your customers can then get to IPv4 content even though they are on an IPv6 address. Now there are some options in the middle. I mentioned Dualstack. There's something called Dualstack Lite, which I believe is where you have, again, your customers have an IPv4 address and an IPv6 can be overlaid on top of that. And what that does, I believe, is it helps you not have to worry about getting all your devices switched over to IPv6, and you can run the two together. Now again, you're still going to need Carrier Grade NAT to help do that tunneling and that translation, and then also to make sure that you've got enough IPv4 addresses on your network. So that's another option. I'm not going to go into that. That's a little over my head, but I can tell you that my main point today was to kind of get through this misconception that you can maybe do without Carrier Grade NAT, but really you're going to need it. So the question is, should you buy it today, or do you wait? You keep buying IPv4 addresses and then eventually you have to buy it later anyway. So my recommendation would be to go with Carrier Grade NAT. So, and of course, if you would like to do that, we have several solutions for that. So that's just a plug for us, although there are lots of solutions out there. So if you are interested in Carrier Grade NAT, just chat us up on this YouTube video, or go to our website, check it out, look for CG NAT products. But it's a service that you are going to need at some point. It's a product that you're going to need at some point, and it might be better to do it now. And there's actually really a really economical solution that can be done with software on off-the-shelf kinds of hardware, x86 hardware. And we can configure all of that for you, and we can make it much less expensive than it would be maybe buying a proprietary kind of CGNet box. So if you priced it in the past and you haven't priced out what would be with us through this virtual kind of CGNet software, then make sure you contact us, because it's probably a lot less expensive than you're thinking, and it may make a lot more sense getting that now than buying IPv4 addresses, especially depending on how many you're going to need. So thanks for joining me. If you found this video helpful, just go ahead and subscribe to our YouTube channel. Click the subscribe button there under the video, and click the little bell to be notified when we're live. Next week, again, I'm going to talk about some of the questions about Carrier Grade NAT, and what about logging IP addresses? Does that work? And what about FTP and gaming and other kinds of applications? Does it break those kinds of things? And I've heard bad things about that. So I'll be covering some of those objections next week. That'll be next week, next Tuesday at 3 o'clock right here for Tech Tuesday, and I will see you then. Thanks for joining me. Bye-bye.